Right, we'll look at ray diagrams today. This is possibly one of the more tricky bits from waves. Certainly something that a lot of people struggle with. So I'm going to go through 3 examples of ray diagrams today. But firstly, I want to look at those 2 rules that we looked at in the last video. The first rule being that, remember, if you've got a ray that travels parallel to the axis, that dashed line there, then it will emerge and go through the focal point. Okay, and the second rule, where any rays that go through the middle of the lens, this point here, will continue going straight through without changing direction, so they won't be refracted. Okay, so let's apply those 2 rules to our ray diagrams. Okay, firstly, this is a convex lens. Okay, this is a convex lens. So if I was to, I've just drawn it very simplified. I've just drawn a line with 2, looks like arrowheads above it. Okay, so the lens will actually look like that. However, I'm going to leave it like that because it's simpler, it's more simple, and it's how you will likely see it in an exam as well. I've also drawn the focal point. I've drawn a focal point here. I've also drawn another focal point, exactly the same position on the other side of the lens. And I've also drawn a point that says 2f. That's twice the focal point away from the lens. Okay, and I've drawn that on both sides as well. Okay, so I've just drawn a red arrow as well. And now that red arrow is our object. Okay, so that's our object. That is the thing that is going to be sending those light rays through the lens. So let's send some light rays through the lens. Let's go for our first one first. Rays parallel to the axis will emerge and go through the focal point. So let's draw a ray from the top of the arrow to the lens, like that. And then remember, it goes through the focal point. So let's draw a ray that goes through the focal point. There we go. Okay, so there's one light ray. Now let's do the second light ray. Let's go for the second rule. Rays going through the center of the lens will continue without changing direction. So let's go through the center of the lens, and the ray will not change direction. So it will just keep going through the center. Now eventually those 2 rays will meet. Okay, and it looks like they meet about there. Okay, so a bit out of my page, but that's okay. So my rays will meet there, which is where I will draw my image. Okay, so I'll draw my image like this, where they meet. That's my image. So you can see that my image has been magnified, so you can see that it's bigger than the object. You can also see that it's upside down, it's been inverted. It's also appearing on the right hand side of the lens. It's appearing on the opposite side of the lens to where the object is. So this is what we would call a real image. Okay, so a real image. And a real image is a type of image that forms on the opposite side of a lens to the object. Okay, a lot of people like to think of these images as being able to be projected on a screen as well. Okay, so if you had a screen like here, okay, you could put that image, you could project that image onto the screen and you'll be able to see it. Okay, your eyes use these types of lenses and they project it onto your retina. Okay, which is like a screen kind of, yeah. So you can project it onto a screen. Some people like to think of it like that. Okay, let's have a look at our second object. Okay, this time our object is placed between the focal point and the lens. So let's go ahead and do our two rules. So rays parallel to the axis will emerge and go through the focal point. Let's do one parallel to the axis and through the focal point. There's one through the focal point. There we go. Right, now let's do another one. So this time we're going to do one that goes straight through the middle and does not change direction. So by our second rule. Okay, so a ray that goes straight through the middle does not change direction. Okay, now something quite interesting is happening. Notice that the rays are actually never going to meet on this side of the lens. They're never going to meet. Yeah, so we can't really draw an image on this side of the lens because the rays don't meet. So what we have to do, similar to the last video, we had to backtrace the rays. Okay, so let's do that. Let's backtrace our rays. Okay, so if I backtrace the rays, they meet somewhere like here, don't they? Okay, so that means our image is going to form there, where they backtrace and combine. Okay, so that's where our image forms. Now, this time it's bigger, so it's also magnified again. It's the right way up, so it's not inverted. But it's also it's on the same side of the lens to the object. Okay. Images that form on the same side of the lens to the object are called virtual images. Okay, so it's a virtual image because it forms on the same size as the object. Now it's the right way up and it's bigger. This is how a magnifying glass works. If you take a magnifying glass and you hold you put the object quite close to it, okay, so within that distance, then you will see a magnified image in the magnifying glass. Okay, if you looked at anything that was further away, like say slightly further away between the focal point and 2 times the focal point, you will see an upside down image. Okay, right. Let's have a look at the final one and final example. So this time we're going to use a concave lens. Okay, I'm representing a concave lens in the same way as a convex lens, except the arrowheads at the top are upside down. Okay, so the lens itself will look like that. Okay, whoops, maybe not like that, like that. So I'm going to draw my object. I'm going to draw it here. Okay, so there's my object. So rays that go parallel to the axis, like so, will always go through the focal point. Now remember, this is a concave lens, okay? So it's not going to go through this focal point. Remember, it goes through the other focal point, okay? So we need to backtrace the ray through this focal point, like so, and then the ray will just emerge like so, okay? Right, let's go through the middle then. So a ray that goes straight through the middle without changing direction, same as before. Straight through the middle without changing direction. There's our ray. Where do they meet? Well, they're not going to meet on this side. They meet sort of here, don't they? Okay, so let's draw our image there. Image. Okay. Now our image is much smaller. Okay, so it's very small. It's also the same way up, and it's on the same side of the lens to the object. What do we call images on the same side of the lens to the object? We call it virtual. Okay. Now a good thing to do would be to get yourself some squared paper and and have a go at some of these examples. Have another go at some of these ray diagrams. Practice it, because it is quite tricky. Okay, but the only way you're going to get good at it is by practicing. So practice it. Have a go at some other images in other positions and see what you get. Okay, and I will see you in the next video.